Hey guys, today we're going to simulate the Skill 66 crap strategy. This is a basic regression strategy to get to a profit within 2 hits. We'll first review the strategy to see how it's played, then we'll simulate 100,000 sessions, and last we'll analyze the data to see how much we might win or lose and what bankroll we'll need to survive. Let's jump straight into it. This strategy is not based around the point number, so we'll first wait for the point to be established. Then we'll bet $66 on the inside numbers. That will be $15 each on the 5 and 9, and $18 each on the 6 and 8. On the first hit, we'll press all the bets up 1 unit to go to $88 inside. On the second hit, we'll collect the winnings and regress down to $44 inside, which is at the table minimum. At this point, the bets on the table are pure profit, so you could change to any strategy. But for today's simulation, I'll just leave the bets there to collect on each hit. Let's run through the strategy with a single shooter. Great, we have a point of 9, so let's get set up. The 4 does not help us. The 8 wins us $21. We'll drop in another $1 and press all the bets by 1 unit. The shooter hit the point, that wins us $28, and we'll take the bets down while we wait for a new point. The new point is 5, and we'll go back up with $44 inside. Now we're out of hand, and any further wins are pure profit. And there's the 7 out. We ended that shooter with a profit of $19. Now that we know the steps, let's run a simulation and see what this strategy can really do. I'll run 100,000 sessions of 10 shooters each. Okay, the simulation threw the dice 8.5 million times, which is 85 throws per session, or 8.5 throws per shooter. That's the expected number. The total bet was just over $100 million, with 55 million won and $57 million lost. That's a house take of 2.6 million and an overall house edge of 2.591%. Let's see how the players did. First, we'll look at the data by shooter. On a per shooter basis, the players won 56% of the time, and they lost only 43.8% of the time. Let's see how much they lost. The most lost on a single shooter was $67. The most won was $775. Here's the histogram. The bins here are $50 wide. The most frequent outcome was a loss of $66 or $67. That's the 43.8% that we saw on the previous chart. The next most likely outcome is a win of $50 or less, which happened 38.4% of the time. And there's a nice spread of wins all the way up to that maximum. Now let's see how the players did over a session that consisted of a full 10 shooters. Here we can see the proportions start to invert, as expected, because playing longer gives that house edge some time to catch up. In this case, 43.8% of the simulated players won money, and a small handful broke even. 56% of the sessions lost money. Let's see how much they won or lost. The worst case for any single session was $667 lost, while the most won was $1,014. Here's the histogram. The bins here are $100 wide. We see a fairly nice bell curve here, centered just below zero. Almost 2 out of 3 sessions ended between plus and minus $200. 96% ended between plus and minus $500. And nearly all of them ended between plus and minus $600. Next, let's determine an appropriate bankroll for this strategy. This is a chart of the player's bankroll at their worst during the session. Just over a quarter of the players were never down more than $100. And over 80% were never down more than $300. Let's look at the report card. We simulated 100,000 sessions of 10 shooters each. The overall house edge was 2.591%. 43.8% of the sessions ended with the player winning some money, while almost 56% lost. The middle 50% of outcomes ranged between a loss of $170 to a win of $113. And the middle 90% of outcomes ranged from a loss of $354 to a win of $340. And players with a bankroll of $510 survived 10 shooters in 99% of all sessions. If you have a strategy you'd like me to simulate, submit it on dicedata.info. You can also send me a message with any suggestions that you have for this channel. As always, thanks for watching and good luck at the tables.